Okay, we're going to take a look at the second half of the geometric sequence lesson that we worked on yesterday. Today, what we want to do is be able to write these geometric sequences as exponential functions. So the reason that we look at geometric sequences right now is because if we were to write them as a function or an equation, it would be exponential. That is, the variable would be the exponent in our equation. Okay. Now, we're going to talk about a couple of new terms. Let me get through the definition, then we'll go back to it. But it says the nth term of a geometric sequence, with the first term being a sub 1 and the common ratio of r, is given by the following formula, where n is any positive number. Okay, so the nth term of the sequence means whatever term you want to see, the first term, second term, third term, fourth term, 50th term. That's what they mean by nth term, whichever one it is you want to see. A sub 1 is the first term of our sequence. Okay, a sub 2 is the second term, a sub 3 is the third term, a sub 4 is the fourth term, and so forth. R is our common ratio. It's what we're multiplying every time to get the next number in our order of our sequence. So when you look at this formula, a sub n, the n can be any number we want, and that's the sequence number. So this is the term of the sequence. A sub n equals a sub 1, first term of the sequence, times r, which is our common ratio, to the n minus 1 power. Okay, notice that there's an n here, this subscript n, and then there's an n here. Those are the same numbers. So to find, let's say, the fifth term in the sequence, we go a sub 5, and then we put a 5 here for the n. Okay, so by putting a 5 in those places, we'll find the fifth term of the sequence by following this formula. Okay, so let's take a look at what we can do. So this says find the first four terms of the sequence given by the following explicit formula. So explicit formula, they're referring to this formula that will generate the numbers in a sequence that is geometric. So as you look at this equation, a sub n equals 8 times 2 to the n minus 1 power. So what you can see here is hopefully the first term in the sequence is 8. Okay, the common ratio is 2, and then this is the formula that will generate those. So let's say I want to find the first term of the sequence. I'm going to let n equal 1. Okay, that will give me the first term in the sequence. So again, I'm going to put the 1 here in place of the n in the a sub n, and I'm going to put 1 in place of the n in the exponent. So I got a sub 1, first term of the sequence, equals 8 times 2 to the 1 minus 1 power. A sub 1 equals 8 times 2 to the 0 power. We all know 2 to the 0 power is 1. So 8 times 1 is 8. So this a sub 1, remember, means the first term of the sequence. So the first term of the sequence is 8. We knew that anyway because they gave it to us right here. Okay, how do we find the second term in the sequence? Well, we take our explicit formula, and now we put 2's in place of the n's. So a sub 2 means the second term of the sequence. Now it's got to be to the 2 minus 1 power, because I'm going to put 2 in place of this n as well, right there in the exponent. Okay, so simplify it. The second term of the sequence equals 8 times 2 to the first power. 2 to the first power is 2. 8 times 2 is 16. The second term of the sequence is 16. How do we find the third term? Same process. A sub 3, third term of the sequence, equals 8 times 2 to the 3 minus 1 power. 8 to the third equals 8 times 2 to the second power. 2 to the second power is 4. 8 times 4 is 32. So the third term in this sequence is 32. Fourth term, because they ask us to find the first 4, a sub 4 equals 8 times 2 to the 4 minus 1. A sub 4, which is the fourth term of our sequence, equals 8 times 2 to the third. 2 to the third is 8. 2 times 2 times 2 is 8. 8 times 8 is 64. Okay, so the first 4 terms of this sequence given by that explicit formula would be 8, 16, 32, 64. Now take a second here. We knew the 8 represented the first term of the sequence, so we knew that that was going to be an 8. And we also can see here the common ratio is 2. That's what the number in parentheses represents. So that means we're going to multiply by 2 each time. So 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. Okay, now we can see that here in the sequence, and then we use the formula up here to get those same numbers. So that's the idea of an explicit formula that represents a geometric sequence and how we can use it. Okay, let's look at another example. Now they're telling us you have to write the explicit formula and then find the 11th term of this sequence. Okay, well, to write the explicit formula, we need two things. We got to know a sub 1 and we got to know the common ratio. Well, a sub 1 is pretty simple. It's the first term of the sequence. That's 512. The common ratio we get, remember, by taking a term and dividing it by its previous term. So if I do 256 divided by 512, it's 1/2. 128 divided by 256 is 1/2. 64 divided by 128 is 1/2. So all I'm doing there is showing you that every time the common ratio is 1/2. So now I know R is 1/2. So I got the two pieces of information I need. Here's our general formula. A sub n equals a sub 1 times r to the n minus 1. I'm going to replace a sub 1 with 512, and I'm going to replace r with 1/2, and it would look like this. So to find any number in this sequence, I can put that number, whatever term it is you want to find, I can put that number in place of n in both these positions, and this will generate that answer. Now they're asking us to find the 11th term. Okay, find the 11th term. So we're going to take our formula that we just found, and now we're going to let n be 11. That will give us our 11th term. So I'm going to replace both those n's with 11. So a sub 11, the 11th term of the sequence, is going to equal 512 times 1/2 to the 11 minus 1 power. So that's a sub 11 equals 512 times 1/2 to the 10th power. Now let's talk about how we simplify this. Remember that this is a division problem raised to an exponent. We can now apply that power of 10 to both of these terms. So it's 1 to the 10th over 2 to the 10th. Okay, that's a rule of an exponent. That's called the quotient rule. Okay, all right, now how does this simplify? Well, 512 is really 512 over 1. That's a fraction. Times 1 to the 10th is 1. 2 to the 10th is 1024. So now I simplify this, do some cross canceling here, and we get the 11th term of the sequence is 1/2 or 0.5. So what that means is if I go back up here, 512, 256, 128, 64 is the fourth term. Take half of that, 32, that's the fifth term. Take half of that, 16, that's the sixth term. Take half of that, 8, that's the seventh term. And if I kept going, when I got to the 11th one, it would be 1/2. Okay. So we want to be able to use the formula, guys. Don't just do what I just said up here. I mean, you can, that works, but we want to be able to work with the formula like this. Okay, let's do another one of these. So same concept, use the explicit formula to find the 8th term of the sequence. So here's our sequence: 3, -24, 192, -1536. Okay, you can see it's going positive, negative, positive, negative. That's okay. We can get that. All right, so write an explicit formula for the sequence. You need to know two things. You got to know the a sub 1, the first term of the sequence, and you got to know the common ratio. A sub 1 simple enough, that's 3. How do I find my common ratio? I divide each term by its previous. So -24 divided by 3 is -8. 192 divided by -24 is -8. -1536 divided by 192 is -8. So each one of these give me an answer -8. That's my common ratio. So the R is -8. Once we have these two, we're ready to write our formula. Remember, I start with the basic, or the standard one. A sub n equals a sub 1 times r to the n minus 1. We're going to replace a sub 1 with 3, and we're going to replace r with -8. So this is what our explicit formula will look like. This little formula here will generate every answer in this sequence. Okay, there she is. Now they're asking us to find the 8th term of the sequence. Okay, so we're going to take our formula and we're going to let n equal 8. That should say 8. Okay, right there. All right, so that says 8. Forget that mistake. So the eighth term of the sequence is 3 times negative 8 times the 8 minus 1 power. That's 3 times negative 8 to the 7th power. Negative 8 to the 7th power. Guys, when you do this in a calculator, make sure you group this base. It's negative 8 to the 7th. That should be negative 2,097,152. And now I got to multiply that answer by 3, and I get negative 6,291,456. That's the eighth term of this sequence. So again, this is a first term, second term, third term, fourth. If I was to multiply negative 1,536 times negative 8, that would give me the fifth term. That answer times negative 8 will give me the sixth term, and then keep going. This is what it would be if we did that. The eighth term is going to be that number right there. Okay. Last example, they're asking us to find the eighth term of the sequence, and now they're telling us what the common ratio is in the first term. So we don't have to deduce that. We just got to write our explicit formula. So let's write an explicit formula for this sequence. So a sub 1 is 2. We know that. R is a third. We know that. So once we have this, we can write the formula by starting with our base and then substituting in what we have. A sub 1 is 2. R is a third. So here's our explicit formula. This thing right here will generate every number in the sequence. All right. They want us to find the eighth one. So that's a sub n equals 2 to the 1/3 to the n minus 1, and n is going to equal 8. All right. So let's put 8 in place of the n's. So the eighth term in the sequence is equal to 8 minus 1 because the n was 8 up here as well. So the eighth term of the sequence is 2 times 1/3 to the 7th. Okay, now 1/3 to the 7th we know is, oops, jumped out of order here, 2 times 1 to the 7th over 3 to the 7th. Okay, that's 2 over 1 times 1 over and 3 to the 7th is 2,187. Now, because that number's odd and 2 is obviously an even number, we can't do any cross canceling here. So if we just, if we just multiply tops and bottoms, numerators across, denominators across, this is my answer. Now, if you do this in a calculator, you're going to get a real ugly decimal. Okay, so that's why I worked it out using, just go ahead and using the fractions and going through this process here. Okay, there is a decimal version of this, but it's long and it's infinite. So we're better off just kind of writing this one out. All right, so that's the eighth term of this sequence. A lot easier to do it this way than it would be to take a third of 2, a third of that answer, a third of that answer, a third of that answer, all the way to here, all the way to the eighth. Okay, so that's how we write a geometric sequence. It's called explicit form or an explicit function, and you guys can write those and apply them and find whatever term they ask you to find. Homework is very straightforward. Hopefully you have a lot of success